Lesson 13-2, Probability Distributions and Frequency Tables. The table at the right shows the speeds of cars as they pass a certain mile marker on Highway 66. The speed limit is 65 miles an hour. What is the total number of cars that pass the marker? What is the probability that a car stopped at a random will be traveling faster than the speed limit? So the first question we're answering is, what is the total number of cars that pass the marker? So all we're doing is we're going to sum everything in this column, and it looks like we get 50. The next question we need to know is, what is the probability that a car stopped at random will be traveling faster than the speed limit? Well, the speed limit is 65, so greater than 65 would be faster than the speed limit. So we're looking at 13 out of 50, which is approximately 26%. Here's another example that is not in your notes. The title of the table is Medicine Taken. So yes, it has been taken, or no, it hasn't been taken. And then over here, our label is cold length. So if they took medicine, their cold lasted 1 to 3 days. So 86 people said yes, 19 said no to that, and then a total of 105 people had a cold from 1 to 3 days. So here are our questions using this table. How many took medicine and their cold was over 1 to 3 days? So this is that number right here. So how many took medicine and their cold was over in 1 to 3 days? So that would be 86 people. How many total had a cold for 1 to 3 days? So that would be our 105. And the question is, what is the probability of taking medicine and having the cold for 1 to 3 days? So that would be 86 people out of 105. And that percentage is 82%. So 82% of the population took medicine and got rid of their cold in 1 to 3 days. Let's try another question. What is the probability of not taking medicine given that you had it 4 to 7 days? So not taking medicine, given that you had it 4 to 7 days. So we'd be looking at 79 out of 95, which gives us 83%. So it looks like if we take medicine, we're more likely to end our cold sooner, whereas if we don't take medicine, our cold will last longer. So those are some things that we can learn from our table. And this type of table is called a frequency table, or a two-way frequency table, because we have two types of data. One that describes is medicine taken, and the other one describes the length of a cold. So our standards are constructing and interpreting two-way frequency tables, and we need to understand that you can use data organized in tables to show frequencies that will help you find probabilities. So a frequency table is a data display that shows how often an item appears in a category. The relative frequency is the ratio of the frequency in the category to the total frequency. So that will give you a percentage or a fraction. So for example, here is a frequency table. It tells us how often each type of music is preferred. So question number 1. A student's music preference is displayed in the frequency table. What is the relative frequency that the preference is for rock music? So we should probably figure out how many people were actually surveyed. So if we add all those numbers together, we get 40. So a favorable outcome would be rock. So there are 10 people that like rock out of the 40 people, which gives us 1/4 or 25%. Remember, your answers can be fractions, percents, or decimals. Number 2, what is the relative frequency for the preference of classical music? So people that like classical, there are 5 of them out of 40. Always reduce your fractions, so we get 1/8, 0.125, or 12.5%. What is the relative frequency of the preference for country music? So country has 8 people out of 40, so that gives me 1/5, or 20%. So what we were looking for on this slide was relative frequency. So relative frequency takes into account the total, where a frequency is just a count of how many people like that kind of music. But now, when I have a relative frequency, I can compare one person or one category to the whole. Where up here, 25% of all the people like rock, 12% like classical, and 20% prefer country. So then we can actually make a comparison using our relative frequency. A student conducts a probability experiment by tossing 3 coins. Using the results below, what is the experimental probability that exactly 2 heads occurred during the trial? So here's what a tree diagram would look like. So on our first toss, we could either get heads or tails. On our second toss, if we got heads on the first, we could still either get heads or tails. On the third toss, depending on what we got on our first and second toss, we could still get heads or tails. So it looks like there are a total of 1, 2, 3, 4, 5, 6, 7, 8 likely outcomes. And that's what is represented up here. Those are all the 8 things that could happen. So they actually did an experiment. So 5 times someone got heads, heads, heads. 7 times someone got heads, heads, tails, and so on. So using the results, what is the experimental probability that we get exactly 2 heads during the trial? So 2 heads. This is 3 heads. This is 2 heads. 1 head, 2 heads, 2 heads, and I think that would be it. The order of the heads doesn't matter, whether it was in our first toss or our third toss or second and third. So what is the experimental probability? So the number of favorable outcomes would be 7 plus 6 plus 2 divided by our total number of outcomes. So that's how many times did we flip the coins all together? 50. So that number reduces to 3/10, or 30%. Probability distribution shows the probability of each possible outcome. And this can be a part of a frequency table. So here's an example. During an intense night of wheat archery, you and your friends keep track of how many bullseyes were hit during each round. You each take 50 turns of shooting 6 arrows. 3 archers hit no bullseyes, 5 hit 1 bullseye, 7 hit 2 bullseyes, 7 hit 3 bullseyes, 11 hit 4, 10 hit 5, and 7 hit 6. What is the probability distribution for the number of bullseyes each archer hit? So let's make a frequency table for the archery game. So reading through those directions again, it says that 3 people hit no bullseyes, 7 hit 2 bullseyes, 5 hit 1, 7 hit 3, 11 people hit 4 bullseyes, 10 people hit 5 bullseyes, 7 hit 6. So this is our frequency. So now what we can do is figure out our probability. So how many total shots were taken? So we add up this column and we get 50. So our probability would then be 3 out of 50, 5 out of 50, and so on. The other thing we could do is then turn that into a percentage. The reason why I prefer a percentage in this example is because some of these fractions would have to be reduced. So if you didn't have them reduced, that would count against you. So you have to make sure you are simplified. And I thought doing a percentage was the easiest way to do that. So then here's the question. What is the probability distribution for the number of bullseyes each archer hit? So that just means what are these numbers, either as reduced fractions, decimals, or percentages. So we finished the table. On Mrs. Gustafson's Chapter 12 circle test, there were 24 A's, 11 B's, 10 C's, 1 D, and 1 F. What is the probability distribution for the test scores? So let's make a table. We'll title it Chapter 12 Test, and we're going to have A's, B's, C's, D's, and F's. So it looks like I had 24 A's, 11 B's, 10 C's, 1 D, and 1 F. So that gives our frequency. The next thing we want to do is get a probability distribution. So our total number of testers needs to be figured out. So I'm going to add 24, 11, 10, and 2. So I get a total of 47 people took the test. So I'm going to show my work over here. So I'm going to do 24 divided by 47, 11 divided by 47, and so on. And then I'll find my percentages. So 24 people is 51%, 11 people is 23%, 10 people is 21%, and then 1 person is 2% of the class. This would be a probability distribution. Here is the exit ticket. Please pause the video until you're ready for the answers. Here are the answers to the exit ticket. This concludes my 13.2 Probability Distributions and Frequency Tables lesson.